Lesson 27, the binomial probability distribution. Example 5. A non-colorblind father and a carrier mother have a 25% chance of having a colorblind child each time they have a child. If this couple were to have 3 children, would it be considered unusual if all of their children were colorblind? Well, this question is referring to, is this particular outcome unusual? Statistically speaking, an event is considered to be unusual when the probability of that event occurring is less than or equal to 0.05. So we need to calculate the probability of the event here in question and compare it to the 0.05 level. If it's less than or equal to 0.05, the conclusion is it is an unusual occurrence. But if the probability is greater than the 0.05, the conclusion is it's not unusual. So in this particular problem, we're focusing on the number of colorblind children this couple could have. And since a child can be born either colorblind or not colorblind, this particular probability follows a binomial random process, since a child is born either colorblind or not colorblind, which gives us 2 possible outcomes. So we can use the binomial probability distribution function to calculate this result. In order to use the binomial probability distribution function, we need to know the value of the 3 variables, n, p, and x. Now, n represents the total number of attempts. In this example, it states that if this couple were to have 3 children, so 3 would be the total number of children in this family, so n equals 3. P represents the probability each time this particular binomial process is conducted. Here, the example states that this particular couple have a 25% chance of having a colorblind child each time they have a child. So the p would equal 0.25. And then the value of x, the random variable, is based on the question. And the question was, would it be considered unusual if all of their children were colorblind? So the value of the random variable that corresponds to all 3 of their children being colorblind would be a value of x equals 3. So the only way for them to have all of their children colorblind was if x equals 3, the total number of children that they have. So using the value of n equals 3, p equals 0.25, and x equals 3, we can use the binomial PDF command in the TI-84 calculator to calculate this result. The reason the binom PDF command would be used is because we're looking at the probability of just equaling 3. And the binom PDF command calculates the probability of x just equaling the value of the random variable x that's inputted into the calculator function. So the probability that all 3 of their children are colorblind can be found by doing the binom PDF with n equals 3, p equals 0.25, and x equals 3. The binom PDF command on the TI-84 calculator is found in the distribution menu. We press second, DISTR, and then arrow down till we find the binom PDF command. Press enter to select, and then we enter the values. N was 3, comma, p was 0.25, comma, and x equals 3. Enter. Here's our result. The probability rounds off to 0.016. Now, comparing the probability of 0.016 to the 0.05, we can see that 0.016 is indeed less than or equal to 0.05. So our conclusion would be, yes, this would be considered unusual. So, if a non-colorblind father and a carrier mother were to have 3 children, it would be considered unusual if all 3 of their children were colorblind, since the probability that all of their children are colorblind, 0.016, is indeed less than or equal to 0.05.